So in the previous video, we saw what is a waypoint controller and what are the equations for the waypoint controller. So in this video, we will just see what exactly do we need to change to implement the waypoint controller. Now, if you look at the previous video, all that we need to implement for this assignment is equations 1 and 2. So equation 1 was the line of sight angle, which is also the theta desired. I mean the side desired, the heading desired, and equation number 2 is the turn rate, which is your this value cmd.angular.z. So once you do that, make sure you define them as global so that they are accessible in the main function. And if you're defining them as global, do put any random value right at the beginning just to make sure that they are recognized as global variables. And after that, once you have done this right here, everything is done it here, you just go to your main function. Inside your main function where you have your publisher and subscriber. So after your subscription, after defining this entire structure where you can put your linear velocity, try to limit the linear velocity to 0.4, anything within 0.4 should be fine, and the angular rate, angular.z is actually the psi dot, the omega equation 2 that you calculate, so that should be coming here. So and then also you need to do something before you publish this to CMD. You have to implement the stopping condition. So the stopping condition is actually defining a buffer zone between the waypoint and the vehicle. So we can say that if the vehicle is within like 20 centimeters or 15 centimeters or 10 centimeters of the within the distance of the waypoint, then we can say that the vehicle has reached the waypoint so that it does not overshoot. So in that case, what we do is that we can check in two ways. One is where you check the difference, the absolute difference between the current x position and the waypoint of the vehicle and the current y position and the y coordinate of the vehicle, and make sure that they are within 10 or 15 or maximum 20 centimeters. And the other way to do that is you can do a range. You can say if the range between them is like 5 centimeters or 10 centimeters at max, then the vehicle can stop. So it can stop there. So if you want a node to like shut down just after it has reached the waypoint, you can put in your if condition and put in your linear x and angular z as 0, because they become 0, and then you can do a shutdown. And if not, you can just keep them as 0 and display a message saying that it has reached the waypoint, and then do a shutdown like a control C. So either way will work, but that is all that you need to change. Do keep in mind that you need to make your file executable, or else it will not run. And remember that Python depends on indentation, so make sure your indentations are correct. Other than that, if you could follow this particular code and you have understood the waypoint controller, you should be able to implement that on the turtlesim as well. Okay, thank you.